Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about 23 EET 105 Fundamentals of Electrical and Electronics Engineering, Unit 3 Wiring, Grounding and Safety for the topic Load Calculations. I discussed general rules for wiring and the need of grounding in the previous YouTube video. If you need to watch that video, I will share the link in the description. Now, in this YouTube video, I am going to discuss about the importance of load calculation and how yourself itself calculated the load in your classroom or the industry or in your home-based application. So here, there are so many wires are come as input and there are so many wires are going as output. How these wires are going to be worked in a electrical load calculation, now we will see. Electrical load basics. An electrical load is a component or portion of a circuit that consumes electric power. Example, it includes countless devices like lighting, appliances and HVAC units. For example, if you are giving this AC source to here, this AC source will pass to either one resistor, one capacitor and one inductor. Now our main purpose is to calculate how much current or voltage is dropped in each element. That is very important. Next, electrical load basics. Electrical loads runs on either direct current or alternating current supply. Most residential devices and industrial machines run on AC only. DC devices such as LED bulbs that contains power electronics that run on AC. Electrical load basics. Some electronics have batteries, that is laptops, cell phones, making them DC loads. Special power electronics on your charging cards make it possible to power DC loads using AC power from outlet. So here the laptop is working on DC load. This DC load can be used by an AC adapter with the DC power supply, and this is the normal AC power source. Load example. The refrigerator which is worked on 120 VAC, the HVAC unit which is worked on 240 VAC, LED tube lights which is worked on 12 voltage DC, dryer which is worked on 12 voltage AC, a desktop computer which is worked on 120 volt AC. Note that all power consumption values can be added as wattage is a common metric. Even though the devices operated at different voltage level, you can still compare and sum their power consumption using watts. Three types of AC loads are used in a general application. One is the resistive load, second one is the capacitive load, and third one is the inductive load. Resistive load is measured in ohms. Current and voltage waves are in phase. Electrical friction reduces current flow and it draws real power in watts. Next, the power factor are very close to unity. This figure shows the load which is connected on resistivity. Next is the capacitive load. Capacitance is measured in farads. Current waves leads to voltage waves. Dielectric material charges up, draws reactive power in VARs with opposite polarity. Power factor leads. Inductive. Inductance measured in henries. Current wave lags voltage wave. Magnetic fields draw reactive power in VARs and the power factor lags. Next, which is very important, how can we calculate? All of the previous example consider instantaneous power consumption, that is a measurement of power consumption of a device at any one point. Load profiles. Load profiles visually displays electrical load over time. It can contain individual loads or an aggregation of many loads. So here if you see, the fridge is working in the timing from 0 to morning 0 to evening 0, how the loads are varying. Here we can calculate both the refrigerator and both washing machine. So depend upon this load how it can be varied. Next is the very important load profile aggregation. Load aggregation can occur at many levels. One is the individual loads, brake panel, building, distribution network, substation and transmission networks. Next is the load profile resolution. The number of data points collected and the time interval indicated the time resolution of data. Higher resolution is useful for understanding variability in power consumption behaviors, and while lower profile resolution is helpful for finding summary information. Next is the load profile resolution. That is the collection rate. It is collected either a second, minute or hour, weekly, monthly. Measurement instruments are restriction collection rate by resolution, limited aggregation level by breaker panel by device, limited type of data by taking voltage, current, frequency, power and power factor. Next by load profile by economic sector. So depend upon the load which are used either in a city, urban or village, it can be varied by industrial, commercial and residential. For example, industrial, large building with a large HV AC system and industrial equipment, it is the largest base load and can be operated at all hours. For example, in your area, if you see any industry which is at the manufacturing of any electronic component, that is under industrial area. Next is the commercial, large buildings with large HVAC systems and many small loads, that is computers, kitchens and lightings. Afternoon peak usually 6 a.m. to 5 p.m. Residential, small buildings with a small HVAC system and small loads. Evening peak usually 4 p.m. to 8 p.m. So seasonal effect. Seasonal effect means it is changed based on temperature and daylight occurs at spend time indoors. Depend on indoor loading and work hour loads. So this is the very important definition. The duty cycle. The duty cycle can be used in combination with power requirements of a device to create a basic estimated load profile. Duty cycle means how much it is on and divided by the total time. So the energy is calculated by using power multiplied by time multiplied by duty cycle. For example, if in a electrical system, that is in your home or a classroom, if the projector is worked on 8 hours, so we can divide 8 hours by the total number of days is hours is 24 hours. So 8 by 24 hours is 33%. That is, we have used this projector on 33%. And how can we calculate the energy? Energy formula is power multiplied by time multiplied by duty cycle. So here this projector will take a power of 3.401 kilowatt and the time is, we can calculate the total time is 24 hours and the duty cycle is out of this 24 hour, 8 hours only the projectors are switched on. So it is 0.33, that is 33 by 100, it is 0.33. So multiplying 3.401 into 24 into 0.33, which will give the 26.94 kilowatt hour in the entire day. So this is the power which is taken by the one projector which is operated in 8 hours. So you can calculate anything. So in this YouTube video, I discussed what is meant by load calculation and the important needs in load calculation, and I give a very little discussion about duty cycle. Next video, I will bring how individual components will deliver individual load in a home or in a college or in industry. Thank you for watching my video. Next topic, I will bring a new innovative idea. Thank you all.